Okay, so here we have a summary of the real number system as well as the non-real number system. So what we have with the real number system is we always start with our natural numbers. So I always explain to my learners a natural number is where you naturally start counting, and you would naturally start counting always at 1. So natural numbers start at 1, and it's all of my positive numbers on my number line. And I say number line because if I look at a number line, for instance, 0, 1, 2, 3, -1, -2, -3, and so on and so forth. And if I go positive and negative, those are the numbers that I have on my number line. I do not include my decimals or my fractions on the number line itself. Okay, so these are all the positive numbers on my number line starting from 1. Then we have the whole numbers. So whole numbers, you will see that it's the n with a little 0 at the bottom. Now, whole numbers start at 0. So it's starting from 0, all the positive numbers on the number line, all the way up to positive infinity. Now, you will see that all natural numbers are also whole numbers, but whole numbers have an extra 0. That's why you will see the symbol being the same as natural numbers, except that it has the 0 included to it. Okay, then we continue to integers. Now, integers is a Z with an extra little line there. Now, integers are all the negative and positive numbers that we have on the number line. Once again, on the number line, we do not include decimals. So it starts by negative infinity and it goes all the way up to positive infinity, all the numbers that do not have decimals and fractions. So you'll see my example here, -3, -2, -1, 0, 1, 2, 3, etc., all the way up to positive infinity. Once again, you'll note all natural numbers are whole numbers, and all whole numbers are integers. As you can see, 0, 1, 2, 3 is also part of the integers. But all integers are not whole numbers, because you see it's the negative that gets added on. Okay, so next, if we have a look at rational numbers looks like a Q, but it has an extra line there. Now, a rational number, the most important thing is that it can be written as a fraction. Now, literally any of these numbers can be written as a fraction if I put it over 1. So here's my example. 7 is a rational number. It can be written as a fraction because I can put it over 1. 7 divided by 1 is still going to be equal to 7. Okay. Can be written as a fraction, or half is a fraction. It is also a recurring decimal. What is a recurring decimal? 0,3 recurring. This just means 0,333333333. So this is what we call a recurring decimal. Or a terminating decimal. 0,124. Stop. There's nothing that continues and continues and continues. 0,4. 1,2. It stops. It's terminating. That's why we call it a terminating decimal numbers. So once again, all natural numbers are whole numbers. All whole numbers are integers, and all integers are rational numbers, because all of these numbers can be written as a fraction if I put it over 1. Okay, but then we have irrational numbers. You will see it's the Q, and it then has a little bit of an apostrophe there. Now, rational numbers cannot be irrational numbers. So that's why I have the straight line here to separate these two. So an irrational number is non-recurring decimals or non-terminating decimals. So it's going to continue and continue and continue. It's never going to stop. So if you put it on your calculator, you're going to see it's going to fill the whole screen. For instance, pi is a non-terminating decimal number. There is no end to the number pi. If you find it on your calculator and you press the change button, you will see that. The square root of 2 is just an example. If you put any prime number under a square root, you will see that the decimal is also non-terminating. And here's an example of a decimal that is non-terminating. Then we also have non-real numbers. Now, there are two different number systems that we use in school. It's the real number system and then the non-real number system. Now, we don't really work with the non-real number system. Learners must just know that it exists. So a non-real number system is if I have a negative number under a square root. You will see if you type in, for instance, square root of -4 into your calculator, it will give you maths error. The same as if I say 4 divided by 0, it's going to give you a maths error. And that's how you know, mostly, that it is in the non-real number system, because we cannot work with that number. The number does not exist within our number system. So we classify this in school as the non-real number system. At university level, this will be called the imaginary number system. But for school purposes, we are going to add this to the non-real number system. And this is how the number system works, and you can now classify each of these symbols along with that table of yours.